Kia ora everyone, hi, it's me, your teacher. I am just making a couple of videos on our organic chemistry topic just to kind of go along with some of the Education Perfect stuff that you've been doing and the worksheets that you've been doing to make sure that we're all kind of on the same page and know what's going on, something that you can kind of look back on later. So the first thing that I'm going to go through is kind of what is an alkane and how do we go about naming them. So naming in organic chemistry is really important because it tells the other person, the other chemist, exactly what molecule structure that you are talking about. It's kind of like a code, it's sort of like a different language, and once you've learned the language, you can use it to name and draw lots of different molecules, and anyone else with that name or structure will be able to draw or name it exactly the same way. So it is important that we know how to do it properly. So this molecule here, we can see that we have got 4 carbons. They are all single bonded together, which tells us that it is an alkane. So alkanes are the most simple type of organic molecule, remembering that organic molecules are molecules that contain carbon in some form. If they are all single bonded together, so there's one line in between each of the carbons, that means that it is an alkane. If there was anything else going on here apart from carbons, hydrogens, and single bonds, it would not be an alkane. So it is really the most simple type of organic molecule. So we want to be able to name this so that someone else could come along and draw this exact picture. So the first thing we need to think about is, number 1, how many carbons are there? And number 2, what type of functional group does this represent? So we've already said there's 4 carbons, and we've said that it's an alkane. So we've answered both of those questions. But unfortunately, 4 carbons alkane is not the name of this molecule. It would be much too easy if it were. So in organic chemistry, we have a set of terms that we use to describe the number of carbons in a molecule. And luckily for you, we use these same terms for the number of carbons in a molecule across all of the functional groups that you'll be learning about today, plus some types of side chains. So you only have to learn it once and you can apply it to lots of different naming examples. So here, let's zoom out a bit. Here I've got the number of carbons and then something called a prefix. So that is a language term meaning the thing that goes at the start of a word. So this will go at the start of the name of our main backbone of our molecule. So the prefix for if there is only 1 carbon is meth, M-E-T-H. For 2, it is eth. For 3, it is prop. For 4, it is bute. So these top 4 here are the ones that are kind of harder to remember because they're not really words that you know so well. One of the ways that I learned how to use it was mice eat peanut butter, which is meth, eth, prop, bute. Past 4 carbons, we get into the same kind of prefixes we use for shapes. So for 5, it is pent, like a pentagon, a 5-sided shape. 6 is hex, 7 is hept, and 8 is oct. You will very rarely be asked to go above 8, but for those of you that are curious, 9 and 10, non, and dec. So these are the words in our code, in our language, that tell the reader how many carbons are in the longest chain in your molecule. In the ones that we're looking at in this video, the longest chain just is the molecule. But in later videos where we start looking at branched chain alkanes and other types of side chain, sometimes it's not so clear what the longest chain is, and it's important that you tell your reader in your name. So our suffix, so this is our prefix, this tells us how many carbons. So prefix tells us how many carbons. Our suffix, the part that goes at the end of the name, tells us what type of organic molecule we have. So in our case, our example is an alkane. It's something that only has single carbon-carbon bonds. So our functional group looks like that. It's a carbon that's singly bonded to another carbon, and our suffix for an alkane is ane, which is nice and handy since it's also the end of the name of the type of molecule. So the suffix, the bit that goes on the end, is -ane. If we were working with an alkene, alkenes have got a double bond and they have a suffix of -ene. So that -ene would tell me that there's a double bond in that molecule somewhere. And again, you can see that that comes from the end of the word. An alkyne is a molecule that has a carbon-carbon triple bond in there somewhere. And you can probably guess, helpfully, what the suffix is going to be there. It is -ine. So again, the end of the name. Now, the ones on the right-hand side are a little bit different. The alcohol is a molecule that has got an OH group. So this is your OH group here, bonded somewhere in your molecule. And the suffix for this is -anol. Now, that isn't the end of your alcohol name, but you will probably have heard of methanol and ethanol, and maybe propanol and butanol as well, which are all forms of alcohol. So an alcohol is a molecule that has an OH group on it and its suffix is -anol. So if you see that -anol somewhere, you know that's an organic alcohol. A carboxylic acid is pretty tricky, don't be too scared, but it has a double bond oxygen and an OH group coming off the same carbon. It looks kind of like a crocodile. Give it some teeth. There we go, yeah. And that's enoic acid. So methanoic acid, ethanoic acid, which is vinegar, propanoic acid, butanoic acid, that kind of thing. And finally, the last one that you need to know for level 2, but obviously we're not getting into any of these things now, I'm just giving you examples of suffixes, is an amine, which is a molecule that has an NH3 group attached to it somewhere. That's a lie, it's an NH2 group, sorry. An NH2 group attached to it somewhere, and the suffix for that is, oops, no, I'm just spelling things wrong, anamine. So it's an amine, hooray. You can also treat this as a side chain, which we'll talk about much later. But these are examples of suffixes. So how do we put these two things together? We've got our prefix, which tells us how many carbons we have, and we have our suffix, which tells us what type of molecule we have. So if we go back to our structure here, we can see we have got 4 carbons, and we have got only CC bonds. So we then have to assign this information to part of our code. So 4 carbons, if you can remember, is bute. So my prefix for my name is going to be bute to tell me that I've got 4 carbons, and the suffix for my carbon-carbon single bonds, nothing else going on here, simplest type of organic molecule, the suffix is -ane. If I put these two things together, I get butane. I have got some examples here for you to pause and try to name. So pause the video now, and then when you come back, I will give you the answers. I'll just wait awkwardly through it. Okay, I assume you paused it. I'm just gonna give the answers now. Okay, so here I've got 3 carbons, 1, 2, 3. If I look at my list, I can see that 3 carbons has a prefix of prop. And because we're working only with alkanes, and I can see that I've only got single bonds in here, it's going to end in -ane. Here for B, I have got 1, 2, 3, 4, 5 carbons. Now, when we get past 4, remember mice eat peanut butter, meth, eth, prop, bute, we start getting into our shapes, like pentagon for 5, so it's pent, to tell me that I have got 5 carbons, and ane, to tell me that this molecule has got only single carbon-carbon bonds. And then finally here, we've got only 1 carbon, so we go back up. 1 carbon is meth, or mice from mice eat peanut butter. And again, there's no other carbons for it to bond to, but this is the simplest organic molecule, and it is meth for 1 carbon, and ane for only single bonds present, methane. You'll sometimes see this written just as CH4. Alright, hopefully that was helpful. In my next video, I will be moving on to naming molecules that have branched chains. So, kia ora.